We're headed for an energy problem of great magnitude and complexity if we continue on the path of dependence and non-renewable sources of energy, such as petroleum and coal. The most prominent effects are increased environmental pollution and worsening climate change like we have never experienced before. Welcome back to Unravel Talks, and today we'll be discussing the future of energy. Energy is the lifeblood of the economy, and we remember its importance when there is a scarcity. But a problem is an opportunity to seek a solution towards a better future. It's important to decarbonize and move to an energy system that is sustainable, secure, more resilient, and, most importantly, affordable. We're all familiar with the common renewable energy sources like solar and wind power. But what about the lesser known, yet incredibly promising energy alternatives? While solar and wind power dominate the renewable energy landscape, researchers and engineers are pushing the boundaries of innovation to harness energy from unconventional sources. Join us as we delve into energy innovation and explore where technology is leading us. Let's start with tidal and wave power, tapping into the immense energy potential of our oceans. Tidal power involves capturing the energy from the natural ebb and flow of tidal currents, typically by deploying underwater turbines or barrage systems. Wave power, on the other hand, harnesses the kinetic energy from ocean waves using floating devices or submerged structures that convert the up and down motion of waves into electricity. Companies specializing in marine energy technology are at the forefront of harnessing both tidal and wave power. They design, deploy, and maintain the necessary infrastructure, such as tidal turbines and wave energy converters, to capture energy from the ocean. Coastal communities and regions with access to strong tidal currents or consistent wave patterns stand to benefit significantly from these renewable energy sources. They offer a predictable and consistent energy supply, reducing reliance on fossil fuels and mitigating climate change. Additionally, marine energy projects can create jobs and stimulate local economies in areas with suitable marine energy resources. Now, moving on to geothermal energy. We're tapping into the Earth's heat reservoirs beneath our very feet. Enhanced geothermal systems and geothermal heat pumps are enabling us to harness this clean and renewable energy source for heating, cooling, and electricity generation. Geothermal energy development involves collaboration between geologists, engineers, and energy companies. Geologists identify suitable geothermal reservoirs. Engineers design and construct geothermal power plants or heat pump systems, and energy companies operate and maintain these facilities. Regions with abundant geothermal resources, such as volcanic areas or geologically active regions, can benefit from geothermal energy. It provides a reliable baseload electricity supply, reducing greenhouse gas emissions and enhancing energy security. Additionally, geothermal heat pumps offer efficient heating and cooling solutions for residential, commercial, and industrial buildings, leading to energy cost savings and environmental benefits. But lastly, let's explore hydrogen energy. Often dubbed the fuel of the future, hydrogen has the potential to revolutionize transportation, industry, and energy storage. The hydrogen industry is made up of different groups, such as companies that create renewable energy, those that make machines for producing hydrogen, businesses that make hydrogen, transport companies, and factories that use hydrogen. They all work together to make, move, and use hydrogen for many purposes. Hydrogen is a kind of clean energy that can do many things. It can be used in cars and trucks that run on hydrogen fuel cells to cut down on pollution, help to make industrial activities like making steel and ammonia cleaner, and store large amounts of energy from renewable sources like wind and solar power. It acts a bit like a battery because it can supply energy, but it needs a constant supply of hydrogen fuel and oxygen to keep working. Inside a hydrogen fuel cell, hydrogen gas goes to one side, called the anode, and oxygen goes to the other side, called the cathode. At the anode, the hydrogen gas is split into positive particles, called protons, and negatively charged particles, called electrons. Now, this splitting is done by a chemical reaction called oxidation. The protons pass through a special material called electrolyte to the cathode, while the electrons travel through a wire generating electricity. Then at the cathode, the protons, electrons, and oxygen all come together to make water, which comes out as harmless water vapor. Additionally, hydrogen can enhance energy resilience and support the integration of intermittent renewables by balancing supply and demand on the grid. The revolutionary potential of these energy sources cannot be overstated. They offer not only cleaner alternatives to traditional fossil fuels, but also the opportunity to transform our entire energy system. By harnessing the power of the ocean, the heat beneath our feet, and the elemental power of hydrogen, we can create a more sustainable and resilient energy future for generations to come. What's important is that green energy, the more you use it, the cheaper it becomes. The future of energy is not limited to conventional renewables. By embracing innovative technologies, we can build a more sustainable and inclusive energy system. And if you're curious about how solar and wind energy help power our path to a sustainable future, click the video now showing on your screen to learn how these renewable powerhouses are key to producing clean energy and driving us towards net zero emissions by 2050.